Okay, we're going to add and subtract radicals today. Here is your first example. We have the square root of 8 plus the square root of 18. Now I wrote the steps on this one. You are to simplify each radical first, and that's in our video from yesterday. 8 is 2 times 2 times 2. Remember, take it down in its factoring tree. 18, 2 times 9. And then 9 breaks down to 3 times 3. And remember, you circle the prime numbers when you get to the bottom. All right, so then remember, because it's a square root, that it takes 2 to bring one number out. So I'm bringing out a 2, and that's onto the square root of 2. Then when I do 18, it takes 2 of the same number, which is 3. I bring 3 out. That's 3 square roots of 2. Once I simplify each radical, you add only like radicals. They have to be exactly the same. So I can only add the square root of 2 with a square root of 2. So now I add my coefficients. 2 plus 3 is 5 onto the square root of 2. Then, is this rational or is it irrational? It is irrational because I have a radical left over. Remember, you can put this in your calculator as well, and then hit equals and hit the SD button and see what it does. It'll fill your calculator up, and the decimal will not repeat and it will not terminate. All right, this problem here, again, we go through those same steps. We want to simplify each part. So I'm going to simplify the square root of 80. You can see that it broke down into 4 2's and a 5. Then when I do that, remember, it's a square root, so it takes 2 of the same number to bring one out. I'm bringing out a 2 and a 2, which is 4, and the 5 stays in. So this one becomes 4 square roots of 5. 45 is 3, 3, and 5. I've got 2 3's. I'm going to bring the 3 out, and that gives me 3 square roots of 5. And don't forget your minus sign. Then this one is already simplified, so I just bring it down. And I add like terms. The ones which are like are 4 square root of 5 and negative 3 square roots of 5. 4 minus 3 is 1. So I have 1 square root of 5 plus 4 square roots of 2, and that cannot be put together. And it is irrational because I have radicals left. So it is irrational. Same thing here now. Look, think. You don't have to do the factoring tree here. You know what the square root of 16 is. It's 4. You know what the square root of 36 is. It's 6. 4 plus 6 is 10, and this is rational. Even though it looks irrational right here, it's not. It's rational. There are no radicals left. It's a rational number. All right, here's a cube root. I do the same thing. I simplify. Y'all, I went ahead. I'm not explaining what I'm doing with this factoring tree each time because you should know. All right, then we have 3, 3, 2, and 3. And this time, instead of it taking 2 to bring one number out, it takes 3. So I have 3 3's. So I'm going to pull that out. That is 3 onto the cube root of 2. That's the only thing left. Then I do this one the same way. This gives me 4 2's. And it takes 3, so I'm bringing out 1 2 and leaving 1 2 in. So they are like terms. They are both cube root of 3. Cube root of 2. So 3 minus 2 is 1. You do not have to write the 1 is understood to be there, just like when you write an X, and you don't usually write 1X. Now, if you want to write that 1 there, that's okay. All right, this one is a little bit bigger. You have to simplify each part. So 8 is 3 2's, and it takes 2 of the same number to bring one out, so I'm bringing out a 2 onto the square root of 2. 27 is 3 3's, and again, this is cube root, and the cube root of 27 is 3. I'm bringing them all out, nothing's left inside. 50 is 2 5's and a 2, so I'm bringing out a 5 onto the square root of 2. 16 has 4 2's. I didn't bother going through that. You can if you want to. So there's 4 2's, and I need 3 of them. So I brought 1 out and left 1 inside. And then I'm going to look at what is like. This problem is here simply because I have a square root of 2 and a cube root of 2, and I don't want you to confuse them as being the same thing. They're not. You have to pay attention to everything. My like terms up here are the 2 square root of 2 and the negative 5 square root of 2. So 2 minus 5 is negative 3 square roots of 2. I pull the 3 down. I don't have another number to add with it because this has no radical, so I don't put anything with it. And then this one, there is no cube root of 2 up here, so I just write them all down. And this, of course, is irrational because I have radicals left. Thank you.